Have you ever thought about what happens when the sun hits that sea of dark roofs in big cities? Temperatures rise drastically and everyone suffers from the heat. But there is a surprisingly simple solution that is revolutionizing cities around the world: green roofs. Today we will show how this technology can reduce urban heat by up to 68 degrees and completely transform the quality of life in metropolises. Comment below which city you are watching this video from. Modern cities face a serious problem that many don't even know about. When we replace green areas with concrete and asphalt, we create the urban heat island effect. This causes temperatures in cities to be significantly higher than in surrounding rural areas. In some metropolises like Tokyo, this increase reaches an impressive 5 degrees Fahrenheit in the annual average. The problem goes beyond thermal discomfort and directly affects our health, energy bills, and even urban infrastructure. But what exactly are green roofs? They are specially designed systems that cover rooftops with living vegetation. We're not just talking about placing a few potted plants on the terrace. A true green roof is a layered structure that includes waterproofing, drainage system, growing medium, and of course, the vegetation itself. The concept is not new. In fact, humans have used some form of green roof for thousands of years. From the famous Hanging Gardens of Babylon to traditional Scandinavian houses with grass roofs. The science behind green roofs is fascinating. When the sun hits a conventional dark roof, up to 95% of that energy is absorbed and converted into heat. A green roof uses this energy in much smarter ways. Part of it is reflected by the vegetation, part is used in the photosynthesis process, and another significant part is dissipated through evapotranspiration. This last process is the true secret of the cooling power of green roofs. Evapotranspiration is the combination of water evaporation from the soil and plant transpiration. It works like a natural air conditioner, cooling not only the building, but also the surrounding air. Studies show that a green roof can reduce surface temperature by up to 133 degrees Fahrenheit compared to conventional roofs and decrease air temperature in the surroundings by up to 68 degrees Fahrenheit. This is enough to make a noticeable difference throughout the neighborhood. There are basically two main types of green roofs. Extensive roofs are lighter, with a substrate layer of only 2 to 6 inches, and low-maintenance plants such as sedums and grasses. They are ideal for large areas and require little intervention after installation. Intensive roofs are true hanging gardens, with deeper substrate, which can reach up to 24 inches, allowing the cultivation of shrubs and even small trees. These require more maintenance but also offer additional benefits, such as leisure spaces and greater biodiversity. The benefits of green roofs go far beyond heat reduction. A building with a green roof can save up to 70% on cooling in hot months. This happens because the vegetation and substrate layer works as an exceptional thermal insulator, reducing heat transfer to the interior of the construction. In climates with harsh winters, the same property helps retain heat inside the building, generating savings in heating as well. Another impressive benefit is stormwater management. In a typical storm, a green roof can retain between 60% to 100% of rainwater, depending on its depth. This drastically reduces runoff, relieving urban drainage systems and decreasing the risk of flooding. The water that eventually leaves the roof is filtered by the substrate, reaching the stormwater systems much cleaner. Green roofs are also true air purifiers. Vegetation captures pollution particles and dust while releasing oxygen through photosynthesis. A study in Toronto estimated that if 20% of the city's buildings implemented green roofs, it would be possible to remove 30 tons of particulates from the air annually. This has direct implications for the respiratory health of the urban population, especially in large metropolises with high pollution levels. Roof longevity is another frequently ignored factor. A conventional roof usually lasts between 15 and 25 years before needing replacement. A green roof can last from 40 to 50 years, doubling or even tripling the useful life of the waterproofing. This occurs because the vegetation protects the membrane from damage caused by ultraviolet radiation and extreme temperature fluctuations. In addition to all these benefits, green roofs create habitats for urban wildlife. Birds, butterflies, and bees, essential for pollination, find refuge in these urban oases. In cities like London, Berlin, and Chicago, researchers have documented hundreds of insect species and dozens of bird species using green roofs as habitat. This helps maintain biodiversity even in highly urbanized environments. But one of the most interesting aspects of green roofs is their impact on people's mental health and well-being. Studies prove that even the simple view of green areas can reduce stress, improve mood, and increase productivity. Buildings with access to rooftop gardens report greater occupant satisfaction and even lower employee turnover in corporate environments. Speaking in concrete numbers, implementing green roofs may seem expensive initially, but the return on investment is surprising. An extensive green roof costs between $10 and $30 per square foot, depending on the system and region. Although this is approximately double the cost of a conventional roof, life cycle analysis shows that the investment pays off in about 6 years, with a return on investment that can reach an impressive 224%. And what about technical limitations? Most buildings can accommodate some type of green roof, especially extensive ones that weigh between 12 to 31 pounds per square foot when saturated. Flat roofs are ideal, but slopes of up to 40% can receive vegetation with appropriate retention systems. Existing buildings generally require a structural evaluation, but many can support extensive systems without the need for reinforcement. Installation is not complicated but requires specific technical knowledge. The process begins with proper waterproofing, followed by the installation of a root barrier, drainage system, specially formulated lightweight substrate, and finally the vegetation. Pre-cultivated modular systems have made installation even simpler, allowing a green roof to be implemented in a matter of days, not weeks. Maintenance varies according to the type of system. Extensive roofs require only 2 to 4 annual visits for removal of invasive plants and inspection of drains. Intensive ones need regular care, similar to a conventional garden. In both cases, the first 2 years are critical for the proper establishment of vegetation, but after that, maintenance becomes minimal, especially in well-designed systems. Cities around the world are recognizing the value of green roofs as a climate adaptation tool. Berlin, Germany, leads the movement with more than 100 million square feet of green roofs. The city has implemented policies that require vegetation on new buildings with flat roofs. Toronto, Canada, was the first city in North America to make green roofs mandatory on buildings with more than 21,528 square feet. Paris plans to add 247 acres of vegetation on roofs and facades as part of its climate resilience strategy. Even organizations like NASA are studying green roofs. Researchers at the Goddard Institute for Space Studies found that widespread implementation of green roofs in cities could significantly reduce urban temperatures and mitigate the effects of climate change on a global scale. For those who want to implement a green roof, the first step is to evaluate the existing structure. Consult a structural engineer to determine the load capacity of the roof. Then consider the type of system most suitable for your local climate and specific needs. Extensive roofs are ideal for those seeking low maintenance and environmental benefits, while intensive ones are perfect for those who want a usable space. Cost can be an initial obstacle, but many cities offer incentives for installing green roofs, such as tax reductions, direct subsidies, or credits for stormwater management. Additionally, energy savings and property appreciation often offset the investment in the medium term. One study showed that properties with accessible green roofs can appreciate by up to 16%. Plant selection is crucial for the success of the project. Native species are generally the best choice, as they are adapted to the local climate and require less maintenance. Succulent plants like sedums are popular in extensive systems for their drought resistance and low maintenance requirements. For intensive systems, the variety is much greater, including ornamental flowers, shrubs, and even urban gardens. Although irrigation is not necessary for all systems, especially in humid climates, some type of watering system may be essential during establishment periods or prolonged droughts. Drip irrigation systems are ideal for their water efficiency. Many modern projects include moisture sensors that completely automate the process. A growing trend is the integration of solar panels with green roofs in what is called a biosolar system. Surprisingly, solar panels work better when cooled, and the surrounding vegetation helps maintain lower temperatures, increasing efficiency by up to 16%. Additionally, the partial shade created by the panels creates diverse microhabitats for plants. A frequently forgotten aspect of green roofs is their noise reduction capability. The combination of substrate, plants, and trapped air can reduce the entry of external sounds by up to 40 decibels. For buildings near airports, busy highways, or industrial areas, this benefit can be as valuable as thermal insulation. Green roofs also play a crucial role in building stronger communities. Community spaces on roofs of schools, hospitals, and residential buildings promote social interaction and environmental education. Students who participate in cultivation on green roofs demonstrate greater ecological awareness and connection with natural processes. If you are thinking about implementing this solution, remember that there are no absolute rules. Each project must be adapted to the specific conditions of the site, climate, and intended use. Consult professionals specialized in green roofs for personalized guidance. There are associations and organizations dedicated to promoting best practices and connecting owners to qualified installers. In an increasingly hot and urbanized world, green roofs represent one of the most accessible and effective solutions for improving the urban environment. By reintroducing nature into previously unused spaces, we are creating more resilient, healthy, and livable cities. The future of sustainable cities is literally above our heads. The transformation of gray roofs into living landscapes is not just an aesthetic matter, but a practical necessity in the face of the climate challenges we face. Each square foot of vegetation added to the urban environment brings us closer to cooler, cleaner cities more connected with nature. So, what are you waiting for to transform your roof into a green oasis? Start exploring the possibilities today. Your building, your community, and our planet will certainly thank you. If you've made it this far, don't forget to subscribe to the channel and leave in the comments a topic you would like us to bring here.